Good morning students. Today we are beginning with Unit 2 Software Engineering Chapter 10 Matrix. 10.5 will be covering 10.5 Matrix for Design Model, 10.6 Matrix for Testing, 10.7 Matrix for Maintenance. Let's begin with the first topic, that is Matrix for Source Code. There is a scientist Holstein. He proposed the first analytical law for the source code by using a set of primitive measures which can be derived once the design phase is complete and code is generated. These measures are listed below. See, he is one of the scientists who has proposed for the source code, matrix for the source code. What is basically a source code? Source code is a program, is a set of programs which solves a particular problem. So there is a big project or a problem. That problem is being written in a programming language. That programming language includes a set of instructions. So that is called as a source code. So what are the basic metrics for those source code? The measures are listed below. Here we abbreviate small n1 to denote the set of distinct operators in a program. What do we mean by operators? Operators are those symbols, those arithmetical operators like logical operators which performs a particular type of calculation. That is, suppose arithmetical operators we are talking about. So it's plus, minus, star represents multiplication, slash for division, percentage, modulo. So these are some of the operators. Now in a program, in a source code, there are various operators which are being used. So we'll be counting those operators only once plus sign is being used, suppose 5 times, so we'll count it as 1. So we'll be counting total number of distinct operators in a program. एक प्रोग्राम में कितने अलग अलग ऑपरेटर्स है उसको हमको काउंट करना है. जैसे सपोज प्लस यूज़ हो रहा है तो उसको एक बार काउंट करना है, माइनस है तो उसको एक काउंट 2 हो जाएगा, एक बार स्टार है मल्टीप्लिकेशन तो 3 काउंट हो जाएगा. तो लाइकवाइज विल बी काउंटिंग द टोटल नंबर ऑफ डिस्टिंक्ट ऑपरेटर्स इन अ प्रोग्राम. Then there is a symbol, that is abbreviation, that is n2, which is equal to the number of distinct operands in a program. What do we mean by basically operands? Operands are those which operates on an operator a plus b. So a and b are the operands which operates on an operator called as arithmetical operators called as plus. So those are the one on which these operators the operator works on those operands. Operands के ऊपर वो operator work करता है. Like we have a minus b. So minus is the operator and a and b are the operands on which that minus is performed. So we'll be counting those operands only once. Distinct operands in a program will be abbreviated as n2. Similarly, capital N1 will be the total number of operators. Now, what is the basic difference between small n1 and capital N1? It includes, capital N1 includes total number of operators, whereas small n1 includes distinct operators. Distinct operators मतलब अलग अलग operators जो है उनको बहुत सारे operators है उसको एक ही बार प्लस को एक बार इंक्लूड कर लिया तो दोबारा नहीं इंक्लूड करेंगे. यहाँ पर टोटल नंबर ऑफ ऑपरेटर्स पूरी प्लस अगर 5 बार इंक्लूड हुआ है तो काउंट 5 आएगा, माइनस 3 बार है तो 5 प्लस 3 8, जबकि यहाँ पर प्लस को एक बार ही काउंट करेंगे और माइनस को एक बार काउंट करेंगे. सो विल बी हैविंग 2 इन दिस केस. से एंड कैपिटल N2 will be the total number of operands. Total number of operands here if in small n2 the distinct operands will be counted. Here the operand will be counted as many times as it appears in the source code of the program. Okay, so there are 4 measures in the matrix of the source code. These are being denoted as small n1, small n2, capital N1, capital N2. Again we'll repeat, small n1 is the distinct operators in a program, small n2 will be distinct operands in a program, capital N1 will be the total number of operators and capital N2 will be the total number of operands. Now the other measures are program length, program volume, program difficulty, development efforts and so on. Now let's calculate the program length. Now program length will be abbreviated as capital N. So capital N equal to N1 log to the base 2 N1 plus N2 log to the base 2 N2. So here again N1 denotes the total distinct operands in a distinct operators in a program. Small n1 denotes distinct operators in a program, whereas capital this small n2 denotes the distinct operands in a program. So multiplication of this n1 into log to the base 2 n1 plus n2 log to the base 2 n2 will be calculated as the length of the program. Length of the program means how many statements are there in a source code in a program. That will be abbreviated as, that will be denoted as capital N. This is one of the matrix of the source code. Now let's see the other matrix, that is capital V, that is program volume. So volume capital V equal to N1, capital V equal to capital N log to the base 2 within bracket small n1 plus n2. This capital N will be the length of the program, is being multiplied with log to the base 2 n1 plus n2, where again we'll repeat n1 will be the distinct operators in a program, total number of distinct operators in a program, whereas small n2 will be the total number of distinct operands in a program. Okay, now the third matrix of the source code will be the volume ratio. So volume ratio is being denoted as capital N. Capital L equal to volume of most compact form of a program upon volume of actual program. So capital L will be less than 1. This value, that is volume ratio, will be less than 1. This formula can also be written as 2 upon n1 into n2 upon n capital N2. This small n1 is the same matrix measure as we have seen in the previous one, which is the small n1 is the distinct operators in a program, and whereas small n2 will be the distinct operands. Capital N1 total number of operators, capital N2 total number of operands. So the formula for the ratio is, volume ratio is 2 upon small n1, that is distinct, total distinct operators, total distinct operands. This is total number of operands. This will be the formula for the volume ratio. Now this difficulty level and the effort, that is program effort and the program difficulty level, are two more matrix of the source code. Now these are calculated as D difficulty level equal to n1 upon 2 into n2 upon n2. This is just opposite of the वॉल्यूम रेशो. वॉल्यूम रेशो का अपोजिट है डिफिकल्टी लेवल. सी हियर वॉल्यूम रेशो इज 2 upon n1. दिस विल बी n1 upon n2. This will be n1 upon 2. Here n2 upon n2, small n2 upon capital N2. Here capital N2 upon small n2. So we can say this difficulty level will be is reverse of the volume ratio. Difficulty level is a reverse of volume ratio. That is difficulty level is equal to 1 upon volume ratio. Now last matrix of the source code is capital E, which is equal to difficulty level into volume. So once you multiply difficulty level into volume, this difficulty level into volume, once you multiply you will get the value as effort as being calculated like this. Now let's begin with a new topic, that is 10.5 matrix for testing. Now testing is basically one of the stage of the software engineering phase, water cycle phase, where after the source code is being developed, after the software has been developed, it is being tested and the test case design being created on the test cases. So that includes the data which is to be input to the source code and the desired output, which expected output you are will be generated. So it depends on the values, negative values, where different types of values will be used in the test cases and the output will be generated. Now if that output which is being generated matches with our expected value, then the testing will be successful. So let's begin with what are the metrics for the testing. Majority of the metrics used for testing focus on testing process rather than the technical characteristics of test. Now generally testers use metrics for these metrics of the testing includes metrics for the analysis, design and the coding to guide them in design and execution of test cases. So these includes basically analysis, design and the coding to guide them in a design and execution of the test cases. The function point can be effectively used to estimate testing efforts. Various characteristics like errors discovered, number of test cases needed, testing effort, and so on can be determined by estimating the number of the function point in the current project and comparing with any previous project. So this function point is one of the metrics which is being one of the metrics for testing, which estimates the testing efforts. Now, matrix for architectural design can be used to indicate how integration testing can be carried out. What do we mean by integration testing? It is basically collaborating or joining different modules testing. Say this is basically what happens. There is a bigger program. There is a problem statement. Now that problem statement is so big that only one user cannot write the source code for that, cannot write the program for that. So it is being divided into different modules. Now different modules will be worked out by a team members. Now after that is being made, the different modules are being integrated together, and the source code is being made. So testing will be performed on different modules. After the testing will be performed on those different modules, it is been integrated. Integration testing will be performed whether it is giving expected result, desired result or not after integrating all those different modules. Integrating मतलब जो अलग अलग modules से उन अलग अलग modules के ऊपर टेस्ट करके उसको जोड़ा जाता है, ताकि हमारा जो बड़ा प्रॉब्लम है वो उसको सॉल्व किया जा सके. तो जब जोड़ने के बाद में तो कोई प्रॉब्लम नहीं आ रहा, कोई टेस्टिंग में कुछ एरर तो नहीं आ रहा है. सो फॉर दैट द इंटीग्रेशन टेस्टिंग इज बीइंग कैरिड आउट. In addition to that, cyclomatic complexity can be used effectively as a matrix in the basis path testing to determine the number of the test cases needed. So this cyclomatic testing is being used effectively as a matrix for the testing, which helps in determining the number of the test cases which are being required. मतलब कितने टेस्ट केसेस चाहिए होंगे, उसके लिए ये साइक्लोमेटिक कॉम्प्लेक्सिटी जो है वो काम आती है. Now there is a testing for object oriented matrix for object oriented testing. Now different types of design metrics that have been direct impact on the testability of the object oriented systems are being considered. While developing metrics for object oriented testing, inheritance and encapsulation are also considered. Now when we talk about object oriented, that is object oriented includes classes, objects, inheritance, encapsulation, polymorphism. These are some of the concepts of the object oriented features. So when we talk about object oriented testing, these testing are being basically based on the inheritance concept and encapsulation. Now the set of metrics for object oriented testing, the first one is lack of cohesion in the methods, LCOM. Now this LCOM indicates the number of the states to be used. LCOM indicates the number one or more same attributes. Okay, the value of this LCOM is 0 if no method access the same attributes. As the value of LCOM increases, more states needs to be tested. So this LCOM, that is lack of cohesion in methods, which means that cohesion is basically the dependency of one statement to another statement in a method. एक मेथड होता है, उसमें काफ़ी सारी स्टेटमेंट्स होती है. वो स्टेटमेंट एक पहली वाली स्टेटमेंट दूसरी वाली स्टेटमेंट के ऊपर कितना डिपेंड कर रही है, दैट इज़ कोहिशन. तो कितना कम डिपेंडेंसी है, लैक ऑफ कोहिशन है, दैट इज़ बीइंग एलकॉम बीइंग टेस्टेड ओवर हियर, कि एक स्टेटमेंट दूसरी स्टेटमेंट से कितना इंडिपेंडेंट है. तो डिपेंडेंसी होनी चाहिए. जब हम एक मॉड्यूल की बात करते हैं, उस मॉड्यूल के अंदर सेट ऑफ स्टेटमेंट्स की बात करते हैं, तो मॉड्यूल शुड बी हाईली कोहेसिव. ओके. And when we talk about one module and another module, the coupling is basically the dependency of one module on the other module. तो coupling हमेशा लो होनी चाहिए. एक मॉड्यूल का डिपेंडेंसी दूसरे मॉड्यूल पे नहीं होना चाहिए. इंडिपेंडेंट मॉड्यूल होते हैं. ओके. The next set of metrics for object oriented testing is percent public and protected, that is PAP. This shows the number of the class attributes which are public or protected. Now what are basically public, protected and private? These are the access specifiers. It gives the accessibility to the data members, to the members of a class. एक class के members की accessibility decide होती है access specifiers से. So public, private and protected, these are the access specifiers. So if we talk about the public access specifier, it means that the accessibility of those members is globally. It can be used anywhere, either within the program or outside the program. Okay. When we create the object of the class, using object of the class, only public members are accessible. But when we talk about the protected members, so protected members are basically inherited, are made only to inherit within the derived class. And there is a third access specifier that is being called as private, which is accessible only within the class. So it is very limited. Now the probability of adverse effects among the classes increases with the increase in the value of PAP, as public and protected attributes leads to potentially higher coupling. So when we talk about the public and the protected attributes, it leads to very higher public coupling. Higher coupling मतलब कि एक मॉड्यूल दूसरे मॉड्यूल से कितना कनेक्टेड है. The third type of matrix for object oriented testing is PAD, public access to data members. Data members को publicly accessible है. This shows the number of the classes that can access attributes of another class. एक class दूसरी class के members को attributes को access कर पा रही है. क्यों? क्योंकि उसके members को हमने कैसे accessibility दी हुई है? Public. Adverse effects among classes increase as the value of the pad increases. जैसे जैसे pad की value increase होती है, उसके adverse effect शुरू हो जाते हैं. Then the next type of matrix is NOR, number of root clauses, number of root classes. This specifies the number of the different classes hierarchies which are described in the design model. Testing effort increases with increase in the number of the root classes. So how many classes are there, how many parent classes are there, that is one of the point which is to be counted, because that acts as a base class for the inherited class. So testing effort increases with the increase in the number of the root classes. जैसे जैसे number of the root classes increase होती है, testing increase हो जाएगा. Now the next is next matrix is fan in. This fan in, FIN, this indicates multiple inheritance. Multiple inheritance. Okay, see multiple inheritance कैसा होता है? एक class होती है, उससे बहुत सारे classes inherit की जा सकती है. If value of FIN, fan in, is greater than 1, it indicates that the class inherits its attributes and operations from many root classes. Note that this situation where fin is greater than 1 should be avoided. Now we will begin with the last topic of this unit, that is matrix for maintenance. Once the source code is being made, testing is being done, the next phase of the water cycle is SDLC cycle, is the maintenance. So now let's see the matrix for the maturity index, that is SMI, provides relating to the stability of the software product. SMI is equal to MT minus FA plus FE plus FD upon MT. FE is the number of the modules that have been changed in the current release. Current release में कितने number of the module में changes है, that is being denoted by FA. Similarly F being denoted by FE. Similarly FA denotes the number of the modules that have been added in the current release. करंट रिलीज में कितने मॉड्यूल्स ऐड हुए हैं, FE में चेंजेस, FA में ऐड, FD में कितने डिलीट हुए हैं. नंबर ऑफ द मॉड्यूल्स दैट हैव बीन डिलीटेड फ्रॉम द करंट रिलीज. ये FD, D फॉर डिलीशन, E फॉर एडिशन, A फॉर एडिशन एंड E फॉर हाउ मेनी आर मॉड्यूल्स आर बीइंग चेंज्ड. ओके. प्रोडक्ट मैट्रिक्स टू स्टेबलाइज as SMI reaches 1.0. This SMI can also be used as a matrix for planning software maintenance activities by determining empirical models in order to know the effort required for the maintenance. Now this ends up with the unit 2 chapter 10, that is matrices.